Hello everyone, I am Rajakumar, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology, Kanyakumari District. Today in this video, I am going to explain the classification and coding systems. Before see the classification and coding system, we should know the reason for using a coding scheme. Three important reasons for using a classification and coding system. First one, design retrieval. Coding system often helps to minimize unnecessary variety of components in a manufacturing plan by making designer aware of existing similar components. Thus, the designer can develop a new part by using a design retrieval system. These types of design takes lesser time than the conventional design. Second one, automated process planning. With the part code for a new part, process plan can be searched and obtained for existing parts with identical or similar parts. Machine design. Using the part code, one can design machine cells which are capable of producing all members of a particular part family. These three reasons for using the code scheme in industry. Then three types of classification coding system. First one, the optics coding system, optics classification system. Second one, the MECH system. Third one, the code system. In first, optics part classification and coding system. This is the most common and widely used coding system. This system was developed by H. Optics of the University of Chen in Germany. In this system uses alphanumerical symbols to represent the various attributes of a part. The optics coding schemes uses the following digit sequence. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D. That means the first, you can see this point 6. The 1, 2, 3, 4, 5 means this is the major design attributes of a part and are called the form code. Next 4 digit 6, 7, 8, 9 are for coding manufacturing related attributes and are called the supplementary code. The letter A, B, C, D code the production operation and sequence and are referred to as the secondary code. The secondary code can be designed by the firm to serve its own particular need. The basic consists of 9 digits which can be extended by added 4 more digits. The first 9 are intended to convey both design and manufacturing data. The interpretation of the first 9 digit is defined in figure. The first 3 digit in the form code and primary design attributes of part such as the external shape, for example rotational versus rectangular, and machine features, for example holes, thread, gear, teeth and so forth. Next 4 digit 6, 7, 8, 9, that is supplementary code. Okay, it is used for some of the attributes that would be useful in manufacturing, for example and dimensions, work material. Okay, then you can see this box. The first box, the form code 1, 2, 3, 4, 5, that is the part geometry and features relevant to part design. Second 6, 7, 8, 9, information relevant to manufacturing. Then next third box exposes the production process and production sequence. It indicated by the A, B, C, D letters. This is the basic structure of optic system. The first column is the first in details of the digit 1. That means the dimension of the length by dimension ratio. Okay. Then second digit, the main shape of the part. Third digit expresses the rotational machining. Fourth digit, plane surface machining. Fifth digit, additional holes, teeth and forming. These are the form code. Next 6, 7, 8, 9 are the supplementary code. 6 means the dimension of the part. 7 means material, and 8 means the original shape of the raw material, and 9 means accuracy of the part. This is the form code of optic system. In digit 1 is indicate the dimension of the part. Based on dimension we are giving the code. Then digit 2 the external shape of the element. Digit 3 internal shape of the element. Digit 4 plane surface machining. Digit 5 axillary holes and gear teeth. Let us examine the form code consisting of the first 5 digits defined generally in figure. The first digit identifies whether the part is rotation or non-rotation. It also describes the general shape and proportion of the part. We limit our survey here to rotational parts processing no unusual features, those with first digit values of 0, 1 or 2. For these classes of work parts, the coding of the first 5 digit is defined in the figure. This is a example figure. We are going to form the form code for this part. Okay, this is one part. Here the both side of step tanning process, and one side only threading on the part. Okay. Given the rotational parts design in figure, determine the form code in the optics parts classification coding system. With reference to figure, the 5-digit code is developed as follows. First of all, length by diameter. Here this part, the maximum length is 1.5. Then diameter is maximum 1.00. So from this we can find out the L by D ratio, length by diameter equal to 1.5. So value we get 1.5. From this value we can see the tabular column, the digit 1, L by D ratio equal to we get the value 1.5. Thus the value is L by D ratio 0.5 less than L by D ratio 0.3. That means L by D ratio value is in between 0.5 to 3 is means the digit value is 1. We put the value is 1. If less than the 0.5 means we can give the first digit value 0. Here we get the value L by D ratio 1.5. So we put 1. This is the first code. Digit 1 symbol, that is the code means 1. Second one, external shape. External shape we can see that this image. External shape means the step tanning and one side only threading. Okay, from this tabular column we can see stepped on both end. The 5 digit number 5 indicate threading and stepped on both end. So we give the second digit code is 5. Then internal shape. Internal shape contain, you can see this internal shape. So functional groove smooth on one step. So we can give these values is 3 equal to 1. Okay. Then plane surface machining is none, above the none. So here plane surface machining, no surface machining is on the work part. So we can give the symbol is that the code value is 0. Then code. Then axillary holes, gear teeth, etc. Digit 5 indicate 5 axillary holes, and here also there is no axillary holes. Okay, so we can give the code 0. Okay, so then for this work material we give the final code 15100. This is the code for the given part. Then MECH class coding system. The MECH class means Metal Institute Classification, was developed by Organization for Applied Scientific Research in Netherlands 1960 and 1970s to develop a system for both the design and manufacturing needs for OIR, that is Organization for Industrial Research. The various functions MECH class was developed for the standardized engineering drawings, retrieval drawings based on classification, standardized process routing, automated process planning. MECH class is an expandable hybrid code system or of up to 30 digits, while the first 12 digits have been standardized. Okay, you can see this image. The image of this code, first the system can be enlarged to 30 digits to cover any classification attributes described by the user. Here you can see this tabular column. The first 4 digit deals with the form, main shape, shape element and position of these elements. Next 4 digit provide the dimension information of dimension information. The main dimension, the ratio of various dimensions and the auxiliary dimensions. Digit 9 and 10 give tolerance information, and the final 2 digit provide a machinability index of the material. The next 18 digit called supplementary digit or optional. These 18 additional digits can be used to code data that are specific to the particular company or industry. Okay. One of the unique features of MECH class system is that the part can be coded using a computer interactive to classify a given part design for the user respond to series of questions asked by the computer. On the basic of response to its question, the computer assign a code number to the parts. In this system, it is difficult to make modification, especially when the code does not provide the necessary information in the first 12 digit. Then code of MDSI system. Manufacturing data system incorporate has developed this classification and coding system called code. It is an 8-digit hybrid code used primarily to classify and coding mechanical piece parts. The typical code structure is: first symbol identify the major divisions. Second symbol express the outer diameter of or section. Third symbol explains the central hole. Fourth symbol, that means fourth digit, holes other than center hole. Then fifth digit, groove threads. Sixth digit expresses the miscellaneous. Seventh digit expresses the maximum outer diameter or section across flats. Eighth digit expresses the maximum overall length. Then benefits of group technology. It facilitates the formation of parts family and machine cells. It permits quick retrieval of design, drawings and process plans. It reduces design duplication. It provides reliable work statistics. It facilitates accurate estimation of machine tool requirements and logical machine loading. It permits rationalization of tooling setup, reduce setup time and reduce production through time. It also rationalization and improvement in tool design. It aids production planning and schedule procedure. It improves cost estimation and facilitate cost accounting procedure. It provides for better machine day tool utilization and better use of tool, fixture and manpower. It facilitates NC part programming. Limitation of group technology. Problems of identifying the part family among the many components produced by a plant. Second, it is a time consuming and expensive process. Third one, the expensive of parts classification and coding. Fourth one, rearranging the machines in the plant into approximate machine cell. Reference: Automation Production System and Computer Integrated Manufacturing by Michael B. Groover. Thank you.